Hi everyone, I'm going to solve this equation k to the power of 6 is equals to 2 to the power of 6. Here we are going to find out the value of k. So let's start our solution. In the first step, I'm going to take this 2 to the power of 6 to the left hand side. K to the power of 6 minus 2 to the power of 6 is equals to 0. Now I'm going to split the powers here. So I'm going to write k to the power of 3 and whole to the power of 2 minus 2 to the power of 3 and whole to the power of 2 is equals to 0. Now here I'm going to apply the algebraic identity, that is a square minus b square is equals to a plus b and a minus b. So here this is our a and this is our b value. Therefore this equation turns to k cube plus 2 cube bracket close k cube minus 2 cube is equals to 0. Now here I will going to apply the zero product rule. So according to that, I will get the two solutions. K to the power of 3 plus 2 to the power of 3 is equals to 0. And k to the power of 3 minus 2 to the power of 3 is equals to 0. Now we're going to solve case 1 here. The case 1 we have k cube plus 2 cube is equals to 0. And here I'm going to apply the algebraic identity, that is a cube plus b cube is equals to a plus b, a square minus ab plus b square. So this is our a and this is our b. Therefore, this equation turns to k plus 2 and k squared minus 2k plus 4 is equals to 0. Now again we get the two solutions from this case 1. So k plus 2 is equals to 0 and here k is equals to negative 2. So this is our first k1 value. Now we're going to solve this second solution, that's the quadratic equation 1. So the second solution from the case 1 we have, that is k squared minus 2k plus 4 is equals to 0. Now I will going to apply here the quadratic formula. This is our a, b and c value. And the formula we have k is equals to minus b plus minus root b square minus 4ac over 2a. K is equals to the b value we have, that is negative 2 plus minus root negative 2 whole to the power of 2, 4 and 1 and then 4 over 2 and then 1. So here k is equals to minus plus. So it will be 2 plus minus root. Here this will be 4. Here 4 times give us 16 over 2. So k is equals to 2 plus minus. Here I will get negative 12 over 2. Now we're going to write this negative 12 in this form. K is equals to 2 plus minus root 12 times negative 1. Now I will going to apply here the radical property. K is equals to 2 plus minus root 12 times negative 1 root over 2. And as you know that the root of negative 1 is equals to iota, the imaginary number. So this will equals to k is equals to 2 plus minus, and this 12 I'm going to write 4 times 3. And here I'm going to write iota over 2. This will, so k is equals to 2 plus minus, and the root of 4 we have 2 root 3 iota over 2. Now we're going to take common here of 2. So this will be equals to 2 and here 1 plus minus root 3 iota over 2. Here this and this get cancelled. So k is equals to 1 plus minus iota root 3. So here we get the 2 more k values. That's the complex solution because we have the imaginary number here, iota. Now we're going to solve our case 2, that is k cube minus 2 cube is equals to 0. Now again, I am going to use the algebraic identity here, that is a cube minus b cube is equals to a minus b and a squared plus ab plus b squared. So here this is our a and b, and this will be equals to k minus 2 and k squared plus 2k plus 4 is equals to 0. So again, we get the 2 solution from the second case. So k minus 2 is equals to 0 and here k is equals to 2. So this is our fourth k value because we have the sixth power. So we'll get the sixth solution for this given equation. Now we're going to solve it out this. K squared plus 2k plus 4 is equals to 0. Here we have this is A, B, and C. Now we're going to solve it out by using the quadratic. So the B value we have that is positive here. So we're going to write 2 plus minus here 2 square minus 4, 1 and 4 over 2 and here 1. So we'll get k is equals to negative 2 plus minus and the square root of 2 we'll get 4 minus and 4 times will give us 16 over 2 and here k is equals to negative 2 plus minus here I will get again negative 12 and over 2. So I'm going to write this negative 12 in the same form like before. 12 times negative 1 over 2 and here k is equals to negative 2 plus minus and I'm going to write here 4 times 3 times root negative 1 over 2 and k is equals to negative 2 plus minus 2 root 3 times iota over 2 and I will going to take the common here. So k is equals to 2 and negative 1 plus minus 3 iota over 2. Here this and this get cancelled. So here I will get k is equals to minus 1 plus minus root 3i. So here again I will get 2 more values. That's the fifth and sixth one. So the total solution from this given equation, we'll get the sixth solution, 4 complex solution, and 2 the real solution. Now we're going to solve our given equation by another method. So here I will going to split the powers first. So k to the power of 3 times 2 is equals to 2 to the power of 3 times 2. Now here I was going to apply the exponential rule. A to the power of m times n is equals to a to the power of m and whole to the power of n. So this can be written as k to the power of 3 and whole to the power of 2 is equals to 2 to the power of 3 and whole to the power of 2. Here I want to root this power, so I will going to take root both the side. K cube whole to the power of 2 is equals to 2 cube whole to the power of 2. Here I will going to take root both the side Here this and this get cancelled. So here k cube is remaining is equals to here this and this get cancelled. 2 to the power of 3 is remaining. Now again, I will want to remove the cube here. So I'm going to take cube both this side. So here this and this get cancelled. This and this get cancelled. So here I will get k is equals to plus minus 2. So from this method, I will get only the real solution. And from the before one, I will get the complex solution. Now, if I want to verify my answer, is it correct or not? So I will going to verify it. So k to the power of 6 is equals to 2 to the power of 6. So I'm going to take the positive 2 here. So 2 to the power of 6 is equals to 2 to the power of 6 is very clear. Now k to the power of 6 is equal to 2 to the power of 6. Here I will going to plug in the negative 2. So here we have the even power. So it will turn into the positive value. So I will get 64 and here 64. So the real solution that we get is absolutely correct. Thank you so very much for watching my video. If you like my video, please do subscribe to my channel.